How long does a latex balloon stay inflated depending on the gas used? Hi, I am going to inflate latex balloons with 5 different gases: oxygen, helium, hydrogen, butane, and air. Inflating and setting up the balloons. I'm going to inflate 10 balloons, using 2 balloons for each type of gas. I start by inflating with air. Why 2 balloons per gas? To ensure the reliability of the test. Indeed, if 2 balloons filled with the same gas deflate at different rates, it would indicate that something went wrong with my experiment. Second balloon with air. Then I inflate with oxygen. Balloons will deflate slowly because their latex membrane is not perfectly airtight. In fact, the gas passes through the latex membrane more or less quickly. It depends on the gas used. In other words, the speed at which the balloon deflates depends on the gas it contains. I heard that gases with lower molar mass diffuse faster. In other words, the smaller and lighter the gas molecules, the faster they escape through the latex envelope of the balloon. If this statement is correct, balloons filled with hydrogen should deflate the fastest, and those filled with butane should deflate the slowest. The following table lists the molar masses of the different gases used, arranged in ascending order. The deflation speed of the balloon should follow the order shown in the table. But will that truly be the case? We're about to find out. Then I inflate with hydrogen. Later in the video, I show how I produce pure hydrogen. I use a mini pump bought on AliExpress to transfer the hydrogen from the Mylar balloon to the latex balloon. It's very easy to power since it's 12 volts. Second balloon with hydrogen. Then I inflate with butane. Butane is a very heavy gas. Second balloon with butane. Let's time-lapse. Speed is accelerated 900 times here. In other words, each second in the time-lapse equals 15 minutes in real time. First surprise, balloons inflated with butane deflate very quickly. So quickly that I smell a slight odor of gas in the room. 4 hours later, the butane-filled balloons are almost completely deflated. The next morning, 20 hours after the start, the hydrogen-filled balloons have almost no lift left. Let's continue the time-lapse. Speed is accelerated 7,200 times here. So each second in the time-lapse equals 2 hours in real time. After 32 hours, the helium-filled balloons have lost most of their lift. Let's recap. 6 hours after start. 12 hours after start. 20 hours after start. 33 hours after start. 37 hours after start. 3 days after start. 4 days. 6 days. We observe that the balloons almost no longer deflate. The air-filled balloons are the largest, followed by those filled with oxygen, helium, hydrogen, and finally butane. Here is the table I showed earlier. We found that butane-filled balloons deflate the fastest, by far. So, butane goes from first to last place. We found that oxygen-filled balloons deflate faster than air-filled balloons, so oxygen loses places in the rankings. We found that air-filled balloons deflate the slowest. Since air is composed of oxygen and nitrogen, we conclude that nitrogen would be the best in the ranking. Here is the ranking based on our observations. If the air-filled balloon deflates less quickly than the oxygen-filled one, it is thanks to the nitrogen present in the air. We deduce that a pure nitrogen-filled balloon would stay inflated even longer than one filled with air. Let's inflate another balloon with butane to do some additional checks. As we have seen, the big surprise came with butane. I inflate another balloon with butane, then I plan to re-inflate the same balloon with air, to check whether the balloon material has been compromised by exposure to butane. The sealing mechanism is carefully checked to ensure that it is completely gas-tight. Let's time-lapse. Speed is accelerated 900 times here. As previously observed, the balloon deflates very quickly. I can assure you, there's absolutely no gas leak from the sealing system. About 4 hours later, the butane-filled balloon is almost completely deflated. The same balloon is then re-inflated with ambient air, using the identical sealing system. Two days later, the balloon is still fully inflated and the latex envelope does not appear to have been damaged by exposure to butane. Conclusion. As we saw, lighter gases don't always spread faster like we might expect. That rule might still hold in general, but other things play a role too, like the way some gases might interact with the latex of the balloon. Second, we've seen that latex balloons filled with lighter-than-air gases like helium or hydrogen don't remain aloft for very long because they deflate quickly. Mylar balloons are a much better option. They hold the gas and remain aloft much, much longer. Here I am making a comparison. On the left is Mylar balloon. On the right is latex balloon, both filled with hydrogen. Let's time-lapse. Speed is accelerated 7,200 times here. So each second in the time-lapse equals 2 hours in real time. 9 days later. Look at that, the Mylar balloon remains well inflated, that's great. 22 days later. The Mylar balloon has deflated a little, but is still in the air. I think the balloon can stay in the air for several more weeks. Now, I am going to show you how I produce pure hydrogen. I used a PEM electrolyzer to produce pure hydrogen. PEM stands for proton exchange membrane. Please note, PEM electrolyzer is not an HHO generator. Inflating such a big balloon takes a little time, so speed is accelerated 900 times here. The volume of this large blue Mylar balloon is nearly 100 liters. The lift of this blue balloon is about 100 grams. Coming soon, inflating latex balloons with other gases like carbon dioxide, methane, propane, and other gases. Stay tuned.